Imagine waking up tomorrow and seeing this headline: scientists have invented a machine that can stop earthquakes forever. No more cities collapsing, no more buildings shaking, no more deadly tsunamis, no more disasters like Japan, Turkey, Nepal, or the recent Venezuela earthquake. Millions of lives could be saved. So here's the question. If scientists already know earthquakes are caused by energy building underground, why don't we simply remove that energy before it explodes? Think about it. We drain water before a dam bursts. We release pressure from gas tanks. We even cool down nuclear reactors. So why can't we slowly drain Earth's energy before it becomes an earthquake? At first, it sounds like one of the greatest engineering ideas ever. Build giant underground machines, collect the energy, generate electricity, save millions of lives. Everybody wins, right? Well, scientists have spent decades thinking about this exact idea, and the answer reveals something almost nobody realizes. Earth isn't storing electricity. It isn't storing heat. It's storing something far more dangerous. Imagine bending a wooden stick. Nothing happens. You bend it a little more. Still nothing. Again, nothing. Then, snap. The energy wasn't created when the stick broke. It was building the entire time. Earth works exactly the same way. The ground beneath your feet isn't one giant rock. It's broken into enormous pieces called tectonic plates. Some are larger than entire continents. And they're always moving. Not fast. Only a few centimeters every year. About as fast as your fingernails grow. Sounds harmless, until you remember, these plates weigh trillions upon trillions of tons. When two plates meet, they don't always slide smoothly. Sometimes they lock together. But the plates keep pushing anyway, every single day, every single year. Stress keeps building. For decades, sometimes centuries, sometimes even longer. Then one day, the rocks simply can't hold anymore. Everything slips at once, and that's an earthquake, which creates an obvious question. If the energy builds up so slowly, why can't we slowly remove it before disaster strikes? Let's imagine you're the world's greatest engineer. Your first idea might be, drill thousands of holes into the fault, release tiny amounts of stress every day, no giant earthquakes, problem solved. Or maybe giant underground shock absorbers, or massive hydraulic systems pushing against the rocks, or gigantic machines that convert the stress into electricity. Honestly, these ideas sound pretty smart, and scientists have seriously discussed versions of them. But every single one runs into the same impossible problem. You're thinking about the fault. Nature is thinking about the entire planet. That fault isn't connected to one rock. It's connected to an entire tectonic plate. Imagine trying to stop two continents from moving. Not two trucks, not two mountains, entire continents. The Indian plate is still crashing into Asia right now. That's why the Himalayas are still growing. Every second, those plates keep pushing with forces so enormous that humanity has nothing capable of resisting them. Even if you somehow relieved stress in one tiny section, the plates wouldn't stop moving. They would simply store the stress somewhere else. You've solved nothing. You've only moved the problem. But what about the energy itself? A single major earthquake can release enough energy to power hundreds of thousands of homes for an entire year. So why don't we capture that? Because earthquakes aren't batteries, they're explosions. Imagine charging a spring for hundreds of years, then releasing all of it in 30 seconds. That's what an earthquake does. Power plants need energy delivered slowly, predictably, every hour, every day. An earthquake delivers almost everything at once. Most of its energy becomes violent shaking, rock breaking apart, friction deep underground, seismic waves racing through the planet. It's like asking, why don't we power cities using lightning? Lightning contains enormous energy, but it happens too fast. It's impossible to control. Earthquakes are exactly the same. Even worse, the machine trying to collect the energy would probably be destroyed by the very earthquake it was trying to harvest. Nature doesn't hand us electricity, it throws an explosion at us. Here's where almost everyone gets confused. People think earthquakes and geothermal energy are the same thing. They're not. Earthquakes come from stored mechanical stress. Geothermal energy comes from Earth's heat. Deep beneath the crust, the inside of our planet is unbelievably hot. The core is almost as hot as the surface of the sun. That heat slowly rises through the mantle. Those slow-moving currents drag the tectonic plates. Those moving plates create mountains, volcanoes, earthquakes, entire continents. In other words, earthquakes aren't the engine, they're the side effect. The real engine is Earth's internal heat, and unlike earthquakes, we can harvest that. Countries like Iceland already produce a large share of their energy from geothermal power. Scientists believe future drilling technologies could unlock even more of this incredible energy source. Not by stealing earthquakes, but by tapping into the heat that's been flowing beneath our feet for billions of years. So maybe we've been asking the wrong question all along. Instead of asking, why can't we stop earthquakes? Maybe we should ask, what would happen if we actually could? Because those same forces that destroy cities also built every mountain you've ever seen, created every continent. Recycled carbon that helps keep Earth's climate stable over geological timescales, and helped make this planet habitable. Earthquakes aren't proof that Earth is broken. They're proof that it's still alive, still changing, still building. The disasters happen because we built our civilizations on top of a planet that never finished constructing itself. And maybe that's the strangest part. From our perspective, an earthquake is one of nature's greatest disasters. But from Earth's perspective, it's just another ordinary day. So here's something to think about. If humanity becomes advanced enough to stop earthquakes forever, should we? Or would we accidentally switch off the very engine that made life on Earth possible?